Good afternoon and welcome to the Deep Space Climate Observatory pre-launch news conference. DSCOVR is a joint mission of NOAA, NASA, and the U.S. Air Force and is a spacecraft that will be launched atop a SpaceX Falcon 9 rocket tomorrow at 6:10 p.m. Eastern Time from Cape Canaveral Air Force Station here in Florida. And we are very pleased today to have the pre-launch news conference to learn more about this important spacecraft and the mission beyond launch. So I would like to introduce our panel members at this time. Immediately to my left, Dr. Stephen Volz, Assistant Administrator of the NOAA Satellite and Information Service in Silver Spring, Maryland. Dr. Tom Berger, Director of the NOAA Space Weather Prediction Center in Boulder, Colorado. Stephen Clarke, NASA Joint Agency Satellite Division Director for the agency's Science Mission Directorate in Washington. Colonel Jason Cothern, Space Demonstrations Division Chief at Kirtland Air Force Base in Albuquerque, New Mexico. Hans Koenigsmann, Vice President of Mission Assurance at SpaceX in Hawthorne, California. And Mike McAleenan, Launch Weather Officer with the 45th Weather Squadron at Cape Canaveral Air Force Station. Gentlemen, welcome. Thank you for being here. We will begin with opening comments, and then we'll take questions both in the room here on our phone bridge, and if you're monitoring on social media, we have a hashtag that you can use to ask your questions. As you see on the screen, watch the spelling. It's hashtag AskDiscover, DSCOVR. And we'll look for your questions a little bit later on. But without any further ado, let's begin with Dr. Volz.
Thank you, Mike, and good afternoon, everyone. Welcome here to the Kennedy Space Center. It's a very exciting time for us to be here. We stand at this point on the threshold of history. We are seeing tomorrow the launch of DSCOVR, the first operational space weather mission to be launched by NOAA into deep space. It's a very exciting time for all of us. This has been a long time coming as well. DSCOVR started as the Triana mission, created and conceived by NASA in the late 1990s. It was completed, tested, and ready for further deployment and for flying when it was canceled around the turn of the century, around 2001. There it went into storage and sat there for several years until in the 2007 to 2008 period, NASA and NOAA together looked at it, evaluated DSCOVR, pulled it out of storage, checked it out to see if it was still a viable and capable instrument and satellite, and determining that it was, and that it could meet NOAA's space weather mission requirements, which we'll talk about a little bit more in the future, in a few minutes. At that point, a partnership was born between NASA, NOAA, and the Air Force, another party who is very interested in space weather forecasts. And the partnership from 2008 on has got us to where we are today. In this partnership, NOAA has the mission leadership responsibility as part of our space weather requirements for the nation. We provide the Space Weather Data Processing Center, we provide all the data archiving for it, and the mission operations, which will be operated out of our NOAA Satellite Operations Facility in Suitland, Maryland. NASA, funded by NOAA, did the original Triana on their own funding, but out of our funding has brought it out of storage, refurbished the spacecraft and the space weather instruments entirely to make them ready for launch at this date. They also, NASA funded on their own funding, evaluated and refurbished the Earth observing instruments, which are secondary payload part of the DSCOVR mission. And the Air Force is providing the launch services for this with their contract with the SpaceX organization. So, space weather, you'll hear a lot more about space weather and why we're interested in and concerned about it from Dr. Berger in a moment. But I'll just lead off by saying that the potential for solar storms. Solar storms can have a potential to provide significant impact to the Earth and to the society. Major economic critical sectors could be affected by it, such as aviation, telecommunications, power grids, and global positioning systems could be affected by the significant solar storms which could come our way. As we rely more on technology, we become more susceptible to the impacts on those technology elements from such things as solar storms, as Dr. Berger will talk about. So we are dependent upon a reliable source of early warning and advance notice of when such things might occur. DSCOVR, when it launches, will take about 110 days to get to its observing point, which is kind of a unique place for us. As I said, it's the first deep space observer we have. It will be sitting at what's called the Lagrange point, which is a gravitationally stable point between the Earth and the Sun, about a million miles away from the Earth, directly in line with the Sun. From that position, it is staring at the sun and taking in situ data of the measurements of the wind, the solar wind, and the coming from the sun in real time, and transmitting that data directly to the Earth. Looking backwards, it's also observing the Earth as a secondary payload opportunity there. At L1, as we call Lagrange Point 1, it will join ACE, the Advanced Composition Explorer, which NASA flew in 1997, providing all of these measurements and others since that period of time. L1, ACE is a venerable satellite, 17 years now, well past its prime lifetime, but still providing accurate data. The importance of the space weather measurements and observations are so critical, it is essential that we get DSCOVR out there to be in party with ACE and to carry on the ACE measurements, at least as far as space weather is concerned, into the future. So as we said, NOAA will be operating DSCOVR out of the NSOF facility, where we will make the data and the observations available to the partners and the public. NOAA's Space Weather Prediction Center, operated out of Boulder, Colorado, will process the space weather data and provide products, forecasts, alerts, and the like to the nation and to users. And the data, once taken, will be archived at NOAA's National Geographic Data Center, also in Boulder, Colorado. So once we launch DSCOVR, what next? We're not just going to sit and watch DSCOVR for 17 years. We know this is a very important measurement to be made, and we're already working within NOAA to figure out what we will do following DSCOVR. What we will have, it takes years to get a satellite developed and on orbit, and we understand the criticality of this measurement, and so we're looking at the next generation of space weather observations and measurements to be made following the DSCOVR mission. So we're very excited about this about today and about what's going on here. This is a set of firsts. Our first deep observing space weather mission, our first venture beyond GEO of any kind, our first launch on SpaceX, 3 very important ones in looking to the future. So I want to give my congratulations to the NASA, NOAA, Air Force, SpaceX, and broad science and engineering and operations team that got us to this point. Some have been working literally for decades for this particular mission to get it ready for launch and for operations. And with that, I'll turn it over to Tom Berger to talk about the more details about the space weather itself. Thanks, Tom.
All right. Thank you, Steve. I'm Tom Berger, the director of NOAA's Space Weather Prediction Center in Boulder, Colorado, the nation's official source for space weather forecasts and alert, and the primary users of DSCOVR data. DSCOVR is a prime example of NOAA's ongoing investment in observational infrastructure to provide reliable, accurate, timely, and actionable environmental intelligence. In this case, environmental intelligence for the near-Earth space environment. Like terrestrial weather forecasting, space weather forecasting begins with observations, primarily from satellites such as DSCOVR. DSCOVR will provide the observations necessary to help us deliver warnings and alerts to industries affected by space weather so they can take action to protect infrastructure and be more resilient in the face of severe events. Impacts from space weather, as Steve mentioned, are very wide-ranging with potentially severe consequences. Many public infrastructure systems such as satellites, GPS systems, commercial aviation, and the electric power industry are vulnerable to space weather, particularly the severe events that can sometimes occur. As our society has grown more dependent on this technological infrastructure, space weather decision support services have become more important to the National Weather Service. SWPC now serves over 44,000 individuals and organizations who have registered to receive our space weather forecasts and products. Now, DSCOVR will be the nation's first operational space weather mission in deep space, as Steve mentioned. It will be located at that L1.1 million miles from Earth, where it will orbit between the Earth and the Sun continually. From this location, DSCOVR will provide forecasters with critical information about the supersonic solar wind that continually streams from the Sun to interact with the Earth's magnetosphere and upper atmosphere. Most of us know this interaction through its generation of the aurora borealis, or northern lights, the most visible aspect of space weather. But DSCOVR will also serve as our tsunami buoy in space, if you will, giving forecasters up to an hour's warning on the arrival of the huge magnetic eruptions from the Sun that occasionally occur, called coronal mass ejections, or CMEs. CMEs are the cause of the largest geomagnetic storms at Earth, some of which can severely disrupt our technological society, causing loss of communications with aircraft, particularly those flying over the poles, damage to satellites in orbit, and even damage to power grid equipment on the ground. So with the launch of DSCOVR, NOAA and SWPC will be better prepared for this critical mission. NOAA has tested all of the data processing elements that need to be in place when DSCOVR reaches the L1 point and is handed over for operations, and we are ready and very excited to embark on this new day for operational space weather forecasting. As Steve also mentioned, DSCOVR will follow NASA's ACE satellite to give forecasters faster and more reliable measurements of solar wind properties, improving their ability to monitor changes in the solar wind and to more reliably predict the arrival time of the big CMEs at Earth. Data from DSCOVR will also feed new models of the Earth's magnetosphere that will enable forecasters to predict the impact of geomagnetic storms on a regional basis. This is new. Right now we predict geomagnetic storms on a planetary basis. Regional basis is coming based on the new models. And forecasters will soon be able to deliver targeted critical information to industries such as the power grid operators in the northeast region of the country, say, who are some of the most at risk from severe space weather events like large CMEs. And it's also important to keep in mind that space weather is not just a national phenomenon, it's a planetary scale phenomenon that affects all nations on Earth. And NOAA has formed strong international partnerships to make the DSCOVR mission a collaborative project across the globe, including the German Aerospace Center in Germany, the National Institute of Information and Communications Technology in Japan, and the Korean National Radio Research Agency, all of whom are part of the DSCOVR mission and will be providing downlink stations to enable the critical 24/7 operations of DSCOVR data required to forecast the space weather. We also have strong partnerships with the Air Force Weather Service and with the UK Met Office in the UK to collaborate on space weather forecasting using DSCOVR real-time data. DSCOVR will ensure that space weather forecasters from NOAA, the Air Force, and other nations have the capability to provide timely, actionable, and relevant space weather watches, warnings, and alerts, the environmental intelligence needed by government and private sector decision makers and emergency managers to ensure that we can respond to anything the sun might send our way. And with that, I'll turn it over to Steve.
Thank you, Tom. Well, it's good to be here at the Cape for the launch of DSCOVR. This is the first launch of a mission managed by the Joint Agency Satellite Division at NASA headquarters, at JASD as we like to call it. We work closely with our NOAA partners with the requirements that they have, and they provide us the funding, and we acquire and develop the satellites for NOAA. And once we launch them and do the on-orbit checkouts and make sure that all the systems are working properly, then we turn the keys over to NOAA to operate those spacecraft, and DSCOVR is being the first one in the JASD portfolio. Also, as Dr. Volz mentioned, there are a couple Earth science instruments on board as secondary objectives of this mission. And those instruments will be acquiring very important Earth science data, including looking at the aerosol content, ozone, and the radiation balance of the Earth. Now, a lot of hard work has gotten us to this point, and the hard work has been accomplished by this extraordinary partnership between NOAA, NASA, the Air Force, and SpaceX, and I too want to thank the extended team for all of their hard work and dedication in getting us to this point, and we're very anxious about getting DSCOVR off. I'd like to share a short video with you which will show some of the DSCOVR processing activities at the Astrotech facility in Titusville. The spacecraft was shipped down from Goddard in November of this year. Here the shipping container is removed, and the spacecraft is wheeled into the clean room at the high bay with the protective cover removed. And inspections were done to ensure everything was good with the transportation. And then the team performed a number of tests to ensure that all the instruments in the spacecraft systems were good. Here the solar array deployment test was performed. It was a very clean processing flow at the Astrotech facility. And here the technicians are doing very close inspections of all the instruments, the various systems on board the spacecraft with the solar arrays deployed prior to packaging up the spacecraft. And here you can see it on top of the payload launch adapter with one of the fairing halves with our DSCOVR logo on the front before encapsulation at the high bay and transportation out to Slick 40. So the spacecraft is in great shape. We're not working any issues at this time. Final closeouts will occur later today, and we're looking forward to SpaceX providing DSCOVR a great ride tomorrow evening on its journey to L1. And with that, I'll turn it over to Colonel Cothern.
Thanks, Steve. Well, good afternoon, everybody. As an Orlando native and a graduate of the UCF College of Engineering, it's really gratifying to be back here in Central Florida for this mission, this important DSCOVR mission. And as the Air Force's Space and Missile Systems Center Advanced Systems and Development Directorate representative to this unique partnership with NASA, NOAA, SpaceX, and the 45th Space Wing, we are excited to be a part of this mission. This is the Air Force's first with SpaceX. The integrated team has put in a tremendous effort to get us to today and our opportunity tomorrow. The spacecraft, as Steve said, is ready, working no issues. The Falcon 9 launch vehicle is ready, working no issues. The range is ready. The teams have been trained and are ready. And we are looking forward to a tremendous opportunity for launch tomorrow. So thank you. And now I'll turn it over to Hans from SpaceX.
Thank you. Thank you. Well, SpaceX is delighted to work with the three agencies, Air Force, NOAA, NASA, and I really would like to thank them for the trust in Falcon 9 and SpaceX in particular. I can give you a couple more details on the first stage and second stage ascent. First stage will burn 165 seconds, a little less than 3 minutes. We will then deploy the second stage. The second stage will ignite and deploy the fairing about 40 seconds into the second stage burn, so it's about 220 seconds. And then at about 8 minutes and 40 seconds, little less than 9 minutes, the second stage will stop the first burn or burn out for the first time and coast for about 22 minutes before it then ignites again for a final fairly large burn that brings the spacecraft then to L1. That happens then 30 minutes after liftoff. Spacecraft separation is going to be 35 minutes after liftoff, and then spacecraft is on its way. Second stage will go through a series of maneuvers, passivation, and safing, venting, basically. I feel like I should probably say a little bit to the landing that we attempt this time. We had some adjustments after the last fairly hard landing on CRS-5, if you recall. We fixed the problems. We hope it will go well this time. The drone ship, just read the instructions as it's named, is out there and waiting for the first stage. However, I really want to point out this is a secondary objective. Again, this is the primary objective is discovery. We're working very hard to get Discovery into the right orbit, into the perfect orbit, basically, and this first stage landing is a secondary objective on the side. Falcon 9 is in great shape. It has a very good static fire on last Saturday. We reviewed the data. It's ready to fly Discover, ready to support. Thank you.
Okay, well, today is one of those days that brings to mind the saying that the good thing about winters along the Space Coast is that they end at 10 a.m. every day. So I think tomorrow is going to be just about a carbon copy of today. But first, let's go to the satellite. And you can see almost a clear peninsula. We got a few scattered clouds just offshore rolling along, and then a kind of a broad swath of moisture off the Keys, southwest of Florida. That might come into play very late on Sunday and into Monday. Let's talk about Monday's forecast. So next slide. See, again, a very, very good weather day. Should wake up to temperatures in upper 40s, maybe 50s, and then gradually increase like today into the 70s. Looking for just a few clouds, mostly offshore, a cumulus variety, and some upper level clouds like there is out there today. Winds will be out of the southeast and very light, 8 to 12 miles per hour or so. So just a very low threat of violation for any kind of cloud cover. That would be if a cumulus cloud were to stray in offshore or that swath of moisture were to roll in a little bit quicker from the southwest than is currently forecast. And just because I know you're going to ask Hans several questions about landing, I went ahead and put the landing forecast up. You can see the waves out there look pretty good. Winds are light, about 10 knots, almost clear skies, and just 2 to 4 feet of seas. So the autonomous drone read the directions vessel will be fairly stable and ready to receive the first stage. Okay, for a delay forecast to Monday, you can see weather does deteriorate a bit. We increased cloud covers at all levels and have increased the probability of violation to 30%, mostly because of thick layer clouds. That's a potential risk to triggered lightning if the thick layer clouds get to around 5,000 feet and are approaching the 0 degrees Celsius to the minus 20 degrees Celsius level in that area. So that's what we're looking for a Monday delay. So just to summarize, tomorrow looks great. I think we should be in a very, very low threat of a violation for a spectacular sunset launch. Thank you.
All right, thank you all. We're ready for questions now. Again, if you are monitoring on social media, please use the hashtag AskDiscover, DSCOVR. And here in the room, please wait for the microphone, state your name and affiliation, and to whom you're addressing the question. We'll start with Marcia Dunn.
Marcia Dunn, Associated Press, from Mr. Koenigsmann. On your secondary objective, was it just a matter of adding more hydraulic fluid? Was that essentially the fix, and are you tweaking anything else about tomorrow's game plan from lessons learned the first time?
Yeah, you got it exactly right. It's basically an added reservoir of hydraulic fluid that gives us the ability to control the fins longer and control the vehicle better. There's a couple differences in the trajectory. We will perform an entry burn and a landing burn, so the speed of the stage coming into the entry is actually higher, and that on the other side makes it a little bit less likely to succeed. So on one side we fix the problem, on the other side this trajectory is a lot more aggressive and a lot more difficult for the first stage secondary. This has nothing obviously to do with the primary discovery mission.
Follow up. Do you know the speed at which it'll be coming in, or how much more than last time?
I believe the dynamic pressure is twice of what it was before. So that would indicate 1.4 on the velocity. Actually, it's not that easy. Twice the dynamic pressure.
Bill Jellin from Spaceflight Insider. Question for Tom. If there's a airplane that's going up over the pole and you detect something and you give him a 15-minute warning, and this is going to be a big event, what can the airplane do at that point to try and avoid the incoming event?
Well, the primary concern there with aircraft over the poles in particular is incoming charged particle radiation associated with coronal mass ejection that's coming in. And what airlines can do over the poles is just simply lower the altitude. The more atmosphere you have over you, the more protected you are from charged particle radiation. You can also divert your route away from the extreme polar routes. That has been done in the past. So there are a couple of ways they can mitigate against the radiation effects of these storms.
Irene?
Thanks. Irene Klotz with Reuters. I have a couple questions about the satellite and then one about the Falcon reentry. For the satellite, do either of you have a mission cost, in possibly including the original Triana price and also including the launch? And if you could recap a little bit about the difference between the original Triana mission, which, if I recall correctly, was basically an Earth observing mission with a camera. I didn't hear any mention of that in your descriptions now, and how that's changed. And I'll ask the other one after.
I'll take the first one. The net cost, the total cost of the DSCOVR mission is approximately $340 million. And to first order is a very close split between the three organizing agencies, Air Force, NASA, and NOAA. With the Air Force with a launch vehicle, NASA with a contributed spacecraft from the Triana heritage, and NOAA from the refurbishment operations and refurbishment operations of the mission now. And as far as the original Triana, I'll turn that over to Steve to address.
So what we've had is really a swap of primary mission objectives here. Triana was primarily focused on Earth observing and Earth science, with space weather being the secondary, and now space weather is the primary mission for DSCOVR. So we did have space weather instruments on board for Triana, but now they become the primary objective of this mission. The Earth polychromatic imager camera is still on there, as is NiSTAR, which is an advanced radiometer. So those two instruments are still on board. They are secondary objectives, and we've checked them out, and they're ready to go.
And if I could, a follow-up to what Steve just said related to the Triana move to DSCOVR, a switch between primary and secondary, where now the space weather is primary, as part of the refurbishment activities that NASA did on behalf of NOAA, was to basically disassemble the spacecraft, pull all the instruments off, check them all, make sure they're all still working, accurate, there's no old parts that need to be replaced, but also to look at it as a system more carefully. And in that process, they discovered some elements of the spacecraft, the reaction wheels, momentum wheels, reaction wheels, the wheels, which would be affecting, for example, the magnetic capability to measure magnetic fields, which they corrected now. So the space weather portions are better than they would have been before because of this, and the Earth as well were refurbished and recalibrated, so they're all in a higher quality than they would have been when they launched 10 years ago.
Thanks. That 340 is for how many years of operations?
It's 2-year basic mission operations.
Thanks. And so on the Falcon 9 flyback, I think I heard you say that there's two engine burns instead of 3 that were done on the
Yeah.
CRS mission. And could you basically maybe just walk us through the sequence of events from first stage separation to all the way to the landing attempt, as far as like the deployment of the grid, the fins, and when the burns would be conducted? Thanks.
Sure. So there's going to be no, we had an early burn originally. That burn is what we can't do this time because all the propellant goes to the primary emission of that burn. We will flip the stage around after separation 180 degrees, and you will probably, I actually forgot to mention, this is a sunset launch, and it's probably very good to see. It's probably very visible in the sky what we do, and you can see the first stage moving around. It will then coast, we'll go through apogee, and we'll begin the descent, and that's when the entry burn happens. The entry burn basically ends with the re-entry and a fin deploy, and it's followed by the landing burn. So it's only going to be 2 burns after the main primary mission ascent burn. And the whole sequence is about 9.5 minutes. So it's shortly after the second stage shuts off the first time when we're going to land.
Okay, we'll take one more here before we go to the phone bridge, and after that we'll field some social media questions. But James, go ahead.
Thanks, James Dean, Florida Today. Maybe for Mr. Clarke or Volz. I know I guess the former vice president's involvement is somewhat of a footnote to the mission at this point, but EPIC will provide the images that were sort of the original inspiration, if I understand correctly. So I just wanted to confirm, basically, will you be providing these images? Will you be making them available online, as again was sort of the original inspiration for this spacecraft? And do you think all these years later those will prove to be important, inspiring images at all, or are these sort of been there, done that kinds of things for us at this point?
So to get to the first part of your question, yes, EPIC will be taking images, full resolution images of the sunlit disk of the Earth, approximately 4 to 6 times a day, and then downloading those images over our Wallops Island ground station, and then those images will be posted roughly a day later, and they'll be posted on a website for everyone to see, a public website, so that those views will be there. The original vision was to have that real time, but we won't be doing that for this mission. It will be those images posted about a day later on the website. And to get back to your, I guess, second part of the question, this is all part of the Earth science secondary objectives. We're going to be able to look at the aerosols, the ozone content, and so forth of the atmosphere from that unique vantage point. So yes, it will provide important Earth science data for all of the science users out there to be able to use. And I think it will be an inspiration for people to see the sunlit disk when they can go online and take a look at it, something that was just taken from a unique vantage point roughly 24 hours before. So I know it'll be for me, and I know my children will be happy to see that kind of thing, and the teachers, they've already talked about it in their schools in Virginia.
And if I could follow on the latency question as well, as we talked about, it is both a space weather primary and an Earth observing secondary. The space weather data will be available within minutes to the Space Weather Prediction Center for the real-time or near real-time forecast alerts. And as Steve said, the Earth observing data will be downlinked on a latency of approximately a day for the Earth observing data sets. But as far as whether it provides a vision or inspiration, the DSCOVR is an important satellite measurement from LEO, from L1, but it's part of a much larger consortium or a constellation of satellite observations that we make. So I think it will be an important addition to an already very capable observation set that we have from geostationary, from low Earth orbit, from NASA, from NOAA, from other satellites. And so it's added to an already very complex and very rewarding set of measurements we make from space. It will be noticed, but in the larger pantheon of all the measurements we're already making.
So I'm sorry, just to follow up with respect to the visual aspect, the images for the non-scientists among us, have we seen this before? A picture of Earth from L1 or anything like this, or is this among the firsts of the mission? And then just again, the extra follow-up I was going to add was just as far as the name change along the way here. Was that a conscious effort to put Triana, in history in the past and start fresh, or what was the motive there?
I would say, as far as whether we've taken visual observations from L1, I don't think that's the case. I could be wrong, but I don't think there are any of the similar nature to this, though it is groundbreaking in that aspect. Changing the name from just Triana to Discover, as we said, we went from primary, became secondary, secondary became primary. This is a mission to be part of the larger it's a deep space mission to contribute to our climate assessments of the solar climate, if you will, between the sun, the Earth, and the dynamics between those two. So it wasn't so much, I would say, an attempt to put something behind us, but to recognize the different nature of this mission and its primary function.
All right, let's go to the phone bridge where Tariq Malik from Space.com is standing by. Tariq, are you there?
Yes. How do you hear me, Mike?
Loud and clear.
Great. Well, thank you. I just had one follow-up question on the satellite, and then also one for SpaceX. So just for the satellite real quickly, I think for Mr. Berger, I'm curious just how long you expect Discover to last. I know it's a 2-year primary mission. ACE has lasted, it seems like, forever. What could this, if you get an extension, the lifespan be for the satellite?
Well, as Dr. Volz mentioned, the 2-year nominal mission lifetime is an underestimate, we hope. We believe when we finally get to L1, we'll have a better estimate of the fuel on board, which will be used to station keep the orbit, and that will ultimately determine how long Discover can operate at the L1 point. With a good insertion and a good orbit, it could go many years beyond the 5-year operational lifetime that's mentioned as well. So it really remains to be seen once we get there how much fuel is left and how much station keeping needs to be done with this particular platform. But we hope for well beyond 5 years, of course.
Thank you. And for Mr. Koenigsmann, you mentioned a lot of the differences between the trajectory for Discover launch versus the Dragon launch just 30 days ago. And I'm wondering what changes have been required for the drone ship itself. Is it further offshore than before? I guess how far, is it out in the Atlantic, and how long would it take to get a return to port, given, say, a successful demonstration? Thank you.
Yeah, so the drone ship is further out, that's true. It's about close to 400 miles. I think it's 370 miles downrange, so it's a lot further out than the last one. That also means that we need more time to get back to port, and actually more time to get there. I believe it is now taking us close to 2 days to get back, but I'm not entirely sure. Sorry, I didn't check that. I checked the distance.
All right, we're back here, and we have Steve Cole, who is with NASA Communications at NASA headquarters in Washington, and he's been monitoring the traffic coming in on the hashtag AskDiscover. And Steve, do we have some questions?
Yes, quite a lot. First one is, what are the advantages of having so many different agencies working in concert on this project?
I'll take that one, Steve. So the different agencies bring different perspectives, different resources, and different technical expertise often to any partnership. Space weather and weather in general is obviously of interest to all. It's a global phenomenon, or actually planetary system phenomenon. So it's of all of our interest to go forward with it. So in this particular partnership, having the Air Force bring its expertise and its interest in getting SpaceX launch vehicle brought forward, NASA's expertise in the Triana satellite, which they originally built, and are the technical experts able to refurbish and design it, NOAA's expertise in space weather and space weather prediction, modeling and analysis, mission operations for operational systems, is a natural fit for the three organizations with their contributions and their resources to come together for a common goal in this particular example.
Okay, next question is, will Discover shorten the forecast time as compared to the ACE satellite currently in orbit?
I'll take that. It will not. It's going to be located at the same basic orbit, the L1 orbit, about 1 million miles from Earth. And so the time from that point until a shock wave from a CME, for instance, hits the Earth is about the same. So it's going to be detecting roughly the same thing that ACE will be detecting and giving us the same lead time that we currently have with ACE.
Similar follow-on question, will Discover data allow for more accurate projections of coming harm from these storms?
The Discover data that we will get is very similar to the ACE data we are getting now. It's what we need to forecast the arrival time of the shock wave once it hits the ACE or Discover spacecraft at L1. Very similar data. It's not really accurate to say that it's more accurate data. For instance, it's the same forecast.
Once Discover is in orbit, will that data be available for schools, for example, to use in real-time teaching?
Yes, it will. That data will go in real time from the satellite down to the Space Weather Prediction Center, where it will be processed, used in our forecast office almost immediately, and also posted to our website, which is spaceweather.gov, and you can get the data there almost in real time.
Okay, still a lot more questions here. How much fuel does it take to keep Discover in the L1 orbit once it gets there?
Well, I guess I'll take that. I don't have exact numbers for that, but we have enough propellant on board to also do mid-course corrections if needed once we've been safely separated from the second stage of Falcon 9 on its way to L1. We continue to look at the trajectory on the journey to determine if slight adjustments to the trajectory are needed. And so we've analyzed that and done a worst-case scenario. That's why we have the amount of propellant on board. I think Tom mentioned that if we need little to no adjustments, that'll just provide more propellant life for the spacecraft.
What was the condition of the Discover spacecraft after sitting in storage for so long?
The Discover spacecraft was in great shape. It was stored in a clean room all this time, so it was protected, and the instruments were under a purge at this time. So the spacecraft was in what I'd call pristine condition, and I think Dr. Volz mentioned that once we pulled it out of storage and did a complete assessment of all of the systems, we actually then started tearing down and refurbishing some of those systems that we felt needed to be upgraded from the technology that was originally in there. But overall, it was in great shape.
Okay. Falcon 9 is proving to be a very reliable launch vehicle. What drove the decision to use it versus, say, a Delta or Atlas rocket?
I think you could look at partnership.
That's a good suggestion. As we mentioned earlier about the value of partnerships, this was a particular example. I'll turn it over to Colonel Cothern in a minute, but the launch requirements to get to L1 could have been addressed by any of several different launch vehicles. This was a particular, it's worth noting this is a Class D or a relatively moderate risk experimental satellite, which is different from, say, a geostationary observing platform or a JWST, a James Webb Space Telescope, which are very high profile, high reliability requirements, which require a different launch vehicle. So with the partnership we had with the Air Force brought forth their recommendation, their proposal for how to get it to space, and as part of our agreement, we work with them. So, Colonel Cothern, would you like to go from there?
Yeah, the only thing I would add to that is that obviously we are interested in, as the Air Force, in competition and looking at who is out there to provide the capabilities that we need for access to space, and SpaceX is one of those, and we wanted to give them an opportunity to do a Pathfinder mission for the Department of Defense and the Air Force, and this was a perfect opportunity.
And I just add also, I mean, this unique partnership we're all talking about here is the agencies continue to talk to each other and look forward for other opportunities to share where we have common objectives, which I think is a great model for cross-agency collaboration.
Let's take two more from social media, Steve, and then we'll take some more in the room, and then we'll get back to...
Great.
I know you have a lot there.
We do. Is it more difficult and complex to get a spacecraft to L1 orbit versus orbiting one into low Earth or geosynchronous orbits?
Wow. Please.
So from our side, in terms of launch vehicle, it is a little bit more effort because you got to adjust this from day to day. So usually we don't have different launch times and different trajectories at the end per day. In this case, we have a little bit more overhead on the mission planning side. But other than that, it's Delta V requirements, and those are high, but certainly not that different from some of the other missions.
And from an observing point of view, when you're in low Earth orbit, for example, it is and often essential. You have a precise crossing time, a precise viewing period. You have to be looking at the ground at the same time of day within a few seconds or minutes. Certainly it's a different position when you're sitting out at L1 with a much looser requirement in terms of where you are in that location. So the observing spot once you're there is probably more forgiving at L1 than it is when you're in low Earth orbit, or even in geostationary where you have a very crowded array of commercial and other satellites up there where you have to be very careful to stay in your zone. It's a lot more forgiving out at L1 once you get there, and that's the task of the launch vehicles to help us get there.
This may be a related question. Why does this launch have an instantaneous launch window?
I'll address that one. I think that's...
Yeah, it's basically targeting a certain spot in space. And since the Earth rotates, it's just once per day the opportunity to get there.
Okay. Bill.
Bill Harwood, CBS News, with two questions. One on the camera. I'm just curious, so much time has gone by, and, everybody knows how cameras advance, and, you buy one at your local store, and it's ever more sophisticated. I mean, I guess what I'm asking is this old technology? In other words, I'm trying to figure out if when the public looks at a picture of the Earth from this camera, are they going to be wowed, or are they going to say, well, that's just whatever? I'm just trying to get a sense of the camera. That's the first question.
Well, I don't know. I think they'll probably be wowed, but when the camera was originally developed, it was cutting-edge technology at that time. And as we've mentioned, when Discover was brought on board here to do this new mission, the instruments were assessed and torn down and looked at the technology. We wanted to be cost-effective on what we were doing for this mission. And so looking at the technology in the camera, it's still very good technology. It might not be cutting edge like today, but the electronics are good, the optics are good. So yes, I think the Epic camera is in good shape, and I don't consider it old technology. It's refurbished, and I think the pixels that are going to be in the views are going to be excellent.
Thanks. One for Hans. Can you tell us what the inclination of the trajectory is going out of here? And I guess I was curious about getting to L1 and the performance required, the burn you're giving up, and so you're accepting the risk of higher dynamic pressure when you come back in. You said that causes a little bit of an issue. I mean, is that any way you can, I'm not asking you to predict the odds of success, but I'm asking you to predict the odds of success. No. Okay, I mean, give us some sense of how confident you are you can pull this off with just the two burns and coming in at a high speed.
Sure. So the inclination is 35 degrees, and that really has more to do with where the second burn is and how to target it. We could have picked other inclinations too. It's a value that we picked because it gave us the most flexibility. With respect to the odds of success on the landing, I think I'm going to stick with 50% after careful deliberation. It's to me, it's when we fixed we fixed one problem that we had last time. There might be other issues ahead of us. Obviously, this is a difficult thing, and then at the same time, the trajectory is more difficult.
Stuart Money, Interspace.net, and my question is for Dr. Berger. Will Discover be at an orbital position where it would provide the first possible warning of a coronal mass ejection, and then looking forward to possible human trips into deeper space? If it's placed well and it lasts long, would that be a sort of a key astronaut warning beacon headed towards Mars?
To answer the first part of your question, yeah, that primary location is the first warning we get of an incoming CME towards the Earth. Now, the L1 point orbits with the Earth, between the Earth and the Sun, so that's really an Earth-directed CME that it's alerting us to. In an astronaut flight out to Mars, for instance, a different trajectory off of that line, that particular buoy, if you will, won't be so useful in forecasting the impact of a CME on an interplanetary flight, for instance, depending on the direction of the flight, of course. And we have other assets available. NASA has research satellites available that can also do similar types of forecasting in different directions. But that's not a primary NOAA operational satellite out there. We use the L1 mission as the primary operational satellite.
Thanks.
Hi, Stephen Clarke with Spaceflight Now. A couple of questions. First for Colonel Cothern, could you talk a little bit about, you mentioned this is a Pathfinder mission for DoD on SpaceX. Can you talk a little bit about what sort of progress this may make toward certification of the Falcon 9 for EELV class missions in the future? Could this data that you get from this mission sort of expedite that process a little bit? And also, could someone address, perhaps Mr. Clarke, someone address when these epic images will be available? How long after launch will these be posted on this website? Thanks.
So yes, unfortunately, neither I or my office have been involved in the new entrant certification, so I can't speak to that. But I can talk about how the integrated team has been working very hard on this particular mission. NASA has been here with their space vehicle since November, I believe, getting that prepared. My team, led by Captain Oba Vincent, has been here since December, working through the holidays, and so we are very prepared and laser focused on the Discover mission.
So the second part of that question to, I guess, my alter ego over there, Steve Clarke. We mentioned before that it takes about 110 days to get to the L1 point, and then we've got to go through a roughly 40-day checkout period of all the systems on board. So at that point, about 150 days after launch is when we'll actually start taking pictures that we can start downloading, as I mentioned, a day later. So if you say about 150 days and we launch tomorrow night, then we'd probably look around the July, August timeframe of when those would become available.
And that's an interesting additional point about the partnership. The NASA, as our development and research development arm for Discover, will be handling the phase to getting to L1, to the checkout, and executing that on behalf of NOAA. And at about the 150-day point, as Steve Clarke mentioned, there'll be an operational handover review. When we'll review all the testing, all the checkout of the spacecraft and its operations, and it'll be handed over to the NOAA satellite facility for routine operations and the posting of all the data at that point on.
Marcia?
Marcia Dunn, Associated Press, with two questions. First one for Dr. Berger. When was the last event of note that was disruptive to Earth life based on a solar event?
Well, I'm not sure what you mean by Earth life.
Our daily life.
The technological effects are primary in space weather. Of course, we haven't had any particular human tragedies yet from space weather, thankfully. But the last sort of major, what we call geomagnetic storm, occurred in early January, actually. It was on a scale of 1 to 5, it was a G3 storm caused by a CME. And it was interesting because in this case, the CME was not easy to detect. The first detection we had of it was at the ACE satellite at L1, and then shortly thereafter it hit the Earth with a relatively strong effect that we weren't predicting at that time. So as I want to follow up on my answer to the answer to the last question as well, which is that the first indication we have of something coming towards us in a geomagnetic storm is from looking at telescopic observations of the sun and seeing an eruption come off the sun. So that's the first indication we have. The second one would be when it hits the ACE or Discover satellite at L1. And that verifies what you see coming off of the sun in general. In the case of the January storm, the G3, there was a very, very faint eruption, and so it was a very surprisingly strong storm that occurred due to this faint eruption. And that's just goes to the fact that we need more research done on how CMEs are formed, how strong they can be, how strong the magnetic interaction can be with the Earth's magnetosphere to cause geomagnetic storming. And it's an ongoing project between NASA and NOAA to better forecast these events.
A quick follow-up. Was there any disruptions that you know of to any satellites, airline traffic?
Not that we know of for that event. It's still early. There may be some out there, and we are researching that.
Okay. And for Mr. Koenigsmann, what do you expect the peak altitude of the booster to be before it starts its descent?
So again, the altitude?
The altitude. What's your maximum altitude are you anticipating for the booster for the landing test?
Yeah, the booster goes to an apogee of about 130 kilometers.
130 kilometers.
James?
James Dean, Florida Today. Hans, I wonder if you could just recap again sort of the recovery team stationing out there with the more aggressive, trajectory. Do they have to be further away? How quickly do you expect to kind of know the outcome of the booster landing? And
they actually are further away from the drone ship. There's more safety distance this time. I still believe that the response will roughly be the same that we had last time. Takes us a couple hours to sort things out, and in this particular case, at 6 o'clock at night, I would guess next morning, in that time frame.
And then with the last attempt, I mean, you guys were nice enough to release a little bit of video. That was pretty cool. But I wondered, and you know, we had the initial close but no cigar comment. I mean, I wonder if you could just give a sense, recap, you know, those final moments. How close was it? You know, basically just that. You know, I mean, did you have to come away with that from a sense of we were almost there, or there's, you know, probably a long way to go?
So we ran out of hydraulic fluid about shortly after the landing burn started. So it was close, I would call this. I mean, but personally, I feel this last time was really an enormous accomplishment on the way to refurbishment and reusability of vehicles. So I don't see this as a failure at all. To me, it's just a development step. And then an improvement is coming this time. It's continuous improvement, basically. We have plenty of opportunities over the next year to try this out and to perfect the landing part. Very important not to get distracted from the primary mission.
We have, we'll take one more here, and then we'll go back to Steve Cole for some more questions from the hashtag AskDiscover.
Bill Jelen from Spaceflight Insider. Talking about the CMEs, there was talk of adding an extra instrument to detect CMEs, but there was no budget for that. So how much better would it have been had you had that instrument added, and how are you detecting CMEs without that?
Well, it's a very similar story to the solar wind measuring instruments in the sense that there is a craft out there called the SOHO satellite with a coronagraph on board. This is the telescopic instrumentation that sees the corona erupt, and so you can detect a CME using this instrument. So we have a coronagraph on board the SOHO satellite that we use as our primary Earth-Sun line indication of a CME heading towards Earth. We did hope at one point to put a coronagraph on Discover. However, as you point out, budgetarily it didn't work out. The SOHO satellite, like ACE, is quite beyond its mission lifetime. I think it's 15 years old. So we are hoping that it will hold out as well, being our primary coronagraph instrumentation. And we do plan for a replacement coronagraph at L1, hopefully within the next 5 to 10 years.
So if Discover has a 15 to 60 minute head start, the telescope that actually sees the eruption, how far in advance does that happen?
Well, that's instantaneous. So the photons are traveling at the speed of light. So we see the eruption come in from SOHO. There is some latency in the data from SOHO because it comes down through the DSN system. We don't get continuous coverage from SOHO. So it's periodically throughout the day we can take down these images and look to see if the flare we see through other telescopes did indeed produce a CME. We can use those SOHO data to predict the speed of the CME and therefore its travel time to Earth.
With the telescope, do you have several hours ahead of time, or is it just?
Well, the fastest CMEs in history have been between sort of 14 to 15 hours. Those are very rare. From anywhere from there until 2 to 3 days is the typical arrival time of a CME. So the telescopic information gives us input to models, which then gives us that first stab at prediction. And it, depending on that speed, again, could be anywhere from 15 hours to several days. And then the L1 instruments out there are the ones that really feel the shock wave and tell us exactly how accurate our predictions were at that point.
Okay, Steve Cole has been monitoring the questions coming in on social media. And Steve, have you got some more questions?
Yes, we do. How is Discover shielded against the very particles that it is monitoring coming to Earth?
Well, excuse me. It does have a sunshade on board that is facing that the sun side. So it does protect the instruments with that sunshade.
If I could follow up, one of the key improvements of Discover instrumentation over the older ACE instrumentation is that it's more robust to the radiation, in particular the solar wind measuring instrument, the Faraday cup we call it, is more robust to radiation storms. So we'll be taking data through radiation storms where previous instruments might have started to black out a bit.
What precautions can be taken on the ground given a warning of an incoming coronal mass ejection detected by Discover?
I'll take that. And there's a lot of things that you can do. As I mentioned earlier, airlines can mitigate against the radiation incoming by taking different routes away from the magnetic poles of the Earth where a lot of these particles come in. They can go to lower altitudes. Power companies, when we give them a warning of a geomagnetic storm, can immediately begin to balance their loads on their grids so that if there are these large currents that are generated in the ground from the geomagnetic storm above the Earth, these currents can go into the power grid without upsetting it too much. So there are a lot of things that can be done on the ground, in particular with power grid systems, to begin to balance the loads and protect against the incoming currents, if any. And they do typically do this at the G3 level and above. Power companies will be taking actions to mitigate against potential geomagnetically induced currents, as we call them.
Okay. How close will Discover be to other satellites at that L1 orbit?
Let's see.
Yeah, that's a tough one. I'm, space is very large out there. So and L1 just happens to be one point between the sun and the Earth. I wouldn't classify it to be close to another spacecraft. It's going to be in its own Lisa-Ju orbit. So I really couldn't comment on an actual value and distance.
So almost like a small planet out there, the satellites are orbiting around that point. They're not all trying to get to that one point.
Right. Thank you.
Will Discover take over the functions of the SOHO satellite should that satellite fail?
No, it won't. As I mentioned earlier, SOHO is unique in that it has a coronagraph telescope, which is our L1 line coronagraph for visualizing coronal mass ejections coming off of the sun. And Discover does not include coronagraph instrumentation. So if SOHO were to fail, we would be dependent on ground-based instrumentation primarily, and perhaps one or two other NASA assets that have coronagraphs but are currently around the backside of the sun and so aren't very useful right now. As they orbit around from the sun, they may become useful again, and their coronagraphs may serve forecasting purposes again.
Will there be a live video of the SpaceX first stage landing on the barge?
No, the video that we can see from here, it's below the horizon from the Cape again. So we won't see a live video. The boat is going to record that, and then we will share this eventually, or not.
Okay, we only have time for one more question, so we'll let Irene have the last question of the day.
Thanks. I'll take advantage and ask three real quick ones for Hans. What's the targeted altitude of the Falcon upper stage for spacecraft separation is the first one?
So the orbit is 185 kilometers. So we do the second burn, and it might rise in those 5 minutes. I'm not sure how much, but it's in the lower hundreds basically still. And then the stage, of course, rises up to almost the same, trailing the spacecraft basically.
Thanks. And I know you took a crack at this before, but is there a way to put in miles per hour or kilometers per hour the speed of the Falcon first stage before the landing burn?
Is there what?
Can you give us some sense of what the projected speed of the Falcon first stage is before the final landing burn?
So the landing burn basically reduces the speed to a few meters per second.
Before that burn?
Before that burn, it travels at low hundreds meters per second.
Thank you. And then the last question is, if this launch goes as planned tomorrow, how quickly are you planning on turning the pad around for the, I'm sorry, I can't remember which satellite, Eutelsat maybe?
The ABS Eutelsat is the next
and
one.
When that would be scheduled, and if you'd also would be able to attempt a flyback on that.
Very quick turnaround on this one. The launch is scheduled by the end of February. I think I have the 27th or the 28th in my head, but in that time frame, right? 27th. Good. Very good. Yeah, 11 o'clock at night. And I don't think this one will be a flyback. This one has no legs.
Okay, I want to thank all you gentlemen for being here. This has been very enlightening. We are flat out of time, unfortunately. And thank you for coming, too. Keep in mind that Discover is scheduled to launch tomorrow at 6:10 and 12 seconds p.m. Eastern Time on a SpaceX Falcon 9 rocket from Cape Canaveral Air Force Station Space Launch Complex 40. Our NASA television coverage will begin at 3:30 in the afternoon tomorrow. And between now and then, and throughout the mission, you can keep track of everything that's happening with Discover by going to the website www.nesdis.noaa.gov/discover. Thank you very much for coming.